Hi, and welcome to a brand new video. Today we're going to be tackling the problem on the screen where you have an array and you need to find the longest increasing subsequence. So you can see here in this example, we start with the smallest number 2, then we go 3, 7, and then 101. And here's the thing. What if we took 5 here? How do we know whether we should take 5 or whether we should take some other number? So in order to solve this problem, we're going to be using something called dynamic programming. I talked about it in this video, and dynamic programming is a way to store previous results so that we don't have to recalculate them. So in order to solve this problem, what we're going to do is we're going to create a single 1D array. I'm just going to be nums.length. And what we're going to do is that in this array, we will store whether or not how long the length of the subarray is in that position. So for example, if it starts with 111 because the subsequence will be 1 if you taken just that number, and then maybe this number is so actually let me make it a little bit more clear by doing dp and nums 1 2 3. So what I'll do is that you'll see at 1 the subsequence currently is just 1, but when we go over to 2 we know that we can have 1 and 2 in a subsequence. So what this will do is they'll take this value here and add it plus 1, and if that's greater than what's currently there, then I'll change it. And then we'll do that again. So in order to do that, all we need to do is create a for loop. I++, and also do another loop inside of that. And what we have to do is we need to say that if nums of I is less than nums of j, which means that they can be in a subsequence together, then we're going to say that dp of j is equal to math.max of nums of dp of j, so what's currently there, or dp of I plus 1. And what this will do is we'll say that maybe there is another subsequence. Maybe there is another one here. So, and maybe there's a 0 here. So this would be 1, 1, 1, 1, 1. This over here, this will become 2. This will also become 2 from this one. And then this, so first you would have this one change this value. So then this would be changed to 4. Or you then this one will compare and see, oh, 4 is greater. So that means I don't need to change it. So that's kind of what I'm looking at. And once we find out this entire dp, we can iterate through it and say that max is equal to max.max of max and m, so we just find the largest number in dp so we can find the largest subsequence and just return max. So now if we run this, you'll notice that with our test sequences, we get 3, 3, 0. And as you can see, it's 4, 4, 1. So it looks like we're missing a 1. And where would that be? Well, remember when you're creating an int array, the default values is 0. And remember, a single integer is its own subsequence of 1, which means we have to do arrays.fill dp with 1. So now if we run this, we're going to get the right results. So this solution allowed us to use dynamic programming in order to solve this problem efficiently. Hope to see you in the next video. Bye!